Facts about acids and bases. This entry was posted on June 12, 2022 by Anne Helmenstein, updated on July 15, 2023. Facts about acids and bases. Most liquids are acids or bases. Acid have a pH less than 7, while bases have a pH greater than 7. Acids and bases are two important types of chemicals you encounter in daily life. All water-based or aqueous liquid are either acidic, basic, or neutral. Acids have a pH value less than 7, pure water is neutral with a pH of 7, and bases have a pH greater than 7. Here is a collection of useful and interesting facts about acids and bases. The pH scale. The pH scale is a way of measuring whether a liquid is an acid, a base, or neutral. The scale runs from 0, strongly acidic, to 14, strongly basic. A pH of 7 is neutral. pH stands for power of hydrogen, and it describes the hydrogen ion, H+, concentration in the liquid. When an acid dissolves in water, it increases the H+ concentration of the liquid. When a base dissolves, it produces hydroxide ions, OH. Hydroxide ions react with H+ naturally in water and lower H+ concentration. So an acid is a hydrogen ion donor, while a base is a hydrogen ion acceptor. Acids have a pH less than 7. When testing with pH paper, acids turn litmus paper red. Acids taste sour. For example, lemon juice and carbonate soda get their sour flavor from acids. However, don't go around tasting random chemicals. Some acids are dangerous. Many acids just feel wet. Others sting when you touch them or feel astringent. Some acids can give you a chemical burn. Examples of common acids include battery acid, stomach acid, vinegar, fruit juices, soda, and coffee. Bases. Bases have a pH greater than 7. Bases turn litmus paper blue. You won't enjoy the flavor of bases. They taste bitter or soapy. Bases feel slippery. Some bases irritate skin or can burn you. Examples of common household bases include baking soda, ammonia, soap, laundry detergent, and bleach. Strong and weak acids and bases. There are strong acids and bases and weak acids and bases. Strong acids and bases completely break apart or dissociate into their ions in water. Weak acids and bases do not completely change into their ions. When you dissolve them in water, the solution contains the weak acid or base, its ions, and water. Examples of strong acids are hydrochloric acid, HCl, and sulfuric acid, H2SO4. Examples of strong bases are sodium hydroxide, NaOH, and potassium hydroxide, KOH. Weak acids include acetic acid, like in vinegar, and formic acid. Baking soda, sodium bicarbonate, and ammonia are examples of weak bases. Interesting facts about acids and bases. Chemists have different ways of classifying acids and bases. The most common ones are Arrhenius acids and bases, Lewis acids and bases, and Bronsted-Lowry acids and bases. Acids and bases neutralize each other, producing water and a salt. If you ever spill a dangerous acid, neutralize it with baking soda or another weak base. If you spill a strong base, like drain cleaner, neutralize it with vinegar before cleaning it up. The word acid comes from the Latin word acere, which means sour. The word base comes from an alchemy concept of a matrix. Alchemists realized an acid reacts with a matrix and forms a salt. Many pure acids and bases are colorless and form solutions that look just like water. However, they react with skin, metals, and other chemicals. While pure water has a neutral pH of 7, it is also both a weak acid and weak base. The reason is because some water, H2O molecules break into H+ and OH ions. Acids and bases and the reactions between them are important for life. In our bodies, stomach acid aids digestion. The pancreas produces a base that neutralizes stomach acid, and the slightly acidic pH of skin protects against pathogens. Our genetic code relies on DNA, which is deoxyribonucleic acid. Acids and bases have commercial uses too. For example, car batteries use sulfuric acid. Cleaning use soaps and detergents. A reaction between acids and bases produces carbon dioxide gas that makes baked good rise.